Okay, good morning. We are the Evergreens. We're the sustainability team for the HSTEM Mass Timber Design. I'm Madison. My teammates are Rachel and Autumn, and our project manager, Audra. So before I go into our role in this project, I'll just give a brief background on what the HSTEM building is. It's going to be a new building next to the Chem Sci building, and it's going to be a center for the research and education of everything that benefits the human health. And our project this semester was a theoretical mass timber design of the HSTEM building using cross-laminated timber. Cross-laminated timber is relatively new to the States, and this design is one of the first of its kind in the US. And this project was completed by dividing the responsibility between 5 teams with different expertise. There was 2 structural teams, one gravity load and one lateral load. There was a civil and transportation team, a construction management team, and our team sustainability. So our team was focused on analyzing the sustainability of the HSTEM building. This was done by analyzing each aspect of the life cycle, including raw materials, transportation, construction, use phase, and the end of life or deconstruction phase. An additional goal that we tasked ourselves with was accomplishing a gold level LEED certification, which we'll go farther into later. So our goal for our life cycle analysis was to analyze the CO2 emissions generated at each stage of the life cycle. So this required using a software known as SEMAPro to get information on the CO2 emissions of each stage of the life cycle. And we also utilized information from facility management on the energy consumption data for Michigan Tech's campus, so we can make estimations of what the HSTEM building is going to need. And Tech is currently using 50% renewable energies provided from wind farms downstate and hopes to be using 100% renewable energies in the next 20 years. So we decided to analyze our life cycle analysis using 3 different levels of renewable energy, 50%, 75%, and 100%, so that we could determine what would be the best option, both economically and environmentally.
So after obtaining a raw materials list from the construction management team and importing that information into SEMAPro, we were able to convert and scale up those emissions to the size of the HSTEM building project for each phase. This can be seen in the graph in the upper right. And so it is important to note that all phases, but especially the transportation and construction phase, are grossly underestimated due to the lack of design impact aspects to the HSTEM building. And so due to this and the fact that the life phase generally has the largest emissions due to it being the longest phase of the life cycle analysis, we decided to focus our life cycle analysis on the life and use phase and kept all other phases the same for easier comparison. We also chose the life and use phase because we were able to get power and cost estimates from HED Designs, since the HSTEM building will not be connected to the street tunnels. And so the way that we chose to mitigate these emissions was increasing the amount of renewable energy, like we said. And this was also compared for the costs in the lower right, which we will dive into later. But an additional assumption we made was that all renewable energy would be coming from downstate and not produced on Michigan Tech's campus. And so jumping right into the results, we have the 50 and 75% renewable energy broken up into individual pie graphs to make a better visual representation of the amount of CO2 emissions. So for 50% renewable energy, there is around 34,000 tons of CO2 equivalents with the life and use phase. This is equal to around 3.5 million gallons of gas, to put it in better terms. And so comparing that to 75% renewable energy, there is a 40% decrease in the emissions. And you can see that for the life and use phase for 50%, it takes up about 75% of the entire emissions, while the 75% only takes up around 61%. So there is going to be an associated increase in cost from this power coming from downstate, but for the 25% increase in renewable energy, it is only around $2,800 extra per year to do this. And so jumping into 100% renewable energy, there is an additional decrease in the amount of emissions. This was expected. However, there will still be associated emissions with the building over the 50-year life period. And this is due to the fact that there is general maintenance that will be needed over the 50-year lifetime of the building. And so there is an increase in cost that is around $10,000 for the HSM building for powering it per year. And so in conclusion, we chose for our life cycle analysis to do 75% renewable energy after comparing the increase in costs and decrease in overall emissions. And our other recommendations that we have for, well, we didn't dive too much into the other design aspects. The raw materials does have a large CO2 emissions from the amount of concrete that is used in this project. So finding an alternative that has lower emissions with it or using concrete is a smart option. And our final recommendation is to add solar panels onto the south side of Kempside. This would do three things. It would cut the costs, the power cost per year for Michigan Tech. It would increase the amount of renewable energy that is going on campus and help with Michigan Tech's goal of the 100% renewable in the next 20 years. And it would aid in our additional goal of having gold level LEED certification, which we'll get into next.
So along with the life cycle assessment, we also looked into LEED certification. LEED stands for Leadership in Energy and Environmental Design, and it's a green certification program that is used worldwide. So there's three benefits to a LEED certified building. The first one is it saves money during the entire life of the building. The second one is it improves the health and quality of life of the individuals that reside inside the building. And then the third one is it helps mitigate environmental impacts, especially surrounding the building. There's LEED certification categories, and they vary from lowest amount of points to highest amount of points. And they're up here, they're certified, silver, gold, and platinum. So like I said, they're achieved by a points rating system. And this helps allocate points for a certification level. Specifically for the HSM building, we determined that the rating system needed to use is the BD&C new construction, which stands for building design and new construction. We chose this rating system because there's no pre-existing structures on the site. And so we'd be building the first structure. Our team also had a goal of gold level certification. And then this is a LEED scorecard. So we use this to allocate points towards the rating system in order to achieve the gold level certification. The rating system that we use has 9 credit categories, and I will be going into each category here. It's important to note that each of the categories has a different number of points allocated towards them. And this is because certain credits are worth more points depending on its impact to the triple bottom line. So we're going to start by looking at location and transportation. Location and transportation has a total of 30 points that you could allocate towards the building. However, we determined that we could only allocate 14. And this specific credit category has a goal of land protection and effective transport. And we can see this here with certain credits like sensitive land protection, as well as access to quality transit. The next category we'll look at is sustainable sites. This has a possibility of 10 credits, and we determined that we would be able to get 5 of those. Sustainability sites has a goal of encouraging development to mitigate surrounding environmental impacts. So the next categories that I'll be going over are water efficiency, energy and atmosphere, and materials and resources. Water efficiency is exactly how it sounds. So you're making the building more efficient with the water use, and this can be done by water metering, and so you're able to see what parts of the building use the most water and being able to mitigate those. The next one is energy and atmosphere, and that's all about reducing the energy consumption in the building. So this is similarly done with water efficiency, so you'd meter the energy used and determine what parts of the building are using the most energy. And then the last one is materials and resources. And this has an intention of being intentional about the products and materials used for the building. There's also a highlight in the demolition of the building. And the CLT paneling used for the HSM building helps in this specific category because it diverts waste in biomaterials. So the last categories I'll talk about are indoor environmental quality, innovation, and regional priority. Indoor environmental quality has a focus of the health and comfort of the individuals inside the building. And so this includes things like interior lighting as well as low emitting materials. So we need to make sure that the users inside the building have enough natural light as well as the artificial light isn't too harsh during the day. And then low emitting materials, we're making sure that the air quality stays in the right levels for the individuals. The next category is innovation, and this encourages developers to create new ideas. This is a little bit different than the other categories, and this is because any credits that are attributed to this category are called pilot credits, and that's because you can try new building designs for this category, if that makes sense. And so even if the designs aren't successful in the building, you can still get points for this because the whole attempt is to try to help with greener development. And so for our team, we decided to have water leak detection and monitoring, all gender restrooms, and bird deterrents for our innovation pilot credits. And I'd just like to say that bird deterrents are stickers or other objects that you can put on windows, and that deters birds from flying into the building. And then the last category I'll talk about is regional priority. And regional priority addresses geographically specific environmental, social equity, and public health priorities. And so in total, we decided that we were able to allocate 72 out of the total 110 points, which puts us in the LEED Gold certified range. And we thought that this was a great starting point because if there's any discrepancies in the construction phases, it's a large enough range that if some of the points weren't able to be allocated anymore, that we could still stay in the gold range.
So to conclude this presentation, the LCA focused on the carbon emissions for the 50, 75, and 100% renewable energy for each stage of the building. Because the life cycle or the life and use phase of the building takes up the most emissions, it is one that we focused on throughout our project, focus our calculations on as well. The 75% renewable energies plan will make the MTU transition to 100% renewable energy in the next 20 years go much smoother. And our life cycle analysis determined that also determined which materials have the highest emissions, and with that we could determine where we could cut emissions. So using CLT and CLT panels rather than steel and cement are one of the first recommendations and easiest ways to cut emissions that we would recommend. Our proposed design also qualifies for the gold level LEED certification. We credited 72 points for this project, which keeps us well within the range of gold LEED certification, which gives us a little room for when inevitable problems come up during construction that may lessen the amount of points that we're able to qualify for. So we recommend that the addition of solar panels to power a portion of the HSTEM building are put onto the chemical sciences and engineering building. We recommend this because the life cycle analysis and the LEED certification, this will help with the life cycle analysis, the LEED certification of cutting emissions and qualifying for more points. It's also important that Michigan Tech becomes a leader in sustainable design and building design, and for the health of our planet, the community, and our economy. MCU has a responsibility to expand its resources in a way that's not going to affect future generations, which is why getting our own renewable energy on campus or getting more renewable energy on campus is really important, along with MCU's goal to get geothermal energy on campus in the next 25 years. So getting renewable energy or this type of renewable energy on campus will really help us in the time in between the geothermal energy that we put on campus. So we also recommend that using resources that are manufactured closer and emit less carbon dioxide emissions during production and use, installation, and deconstruction. That will help with the life cycle analysis, once again, lowering carbon emissions. And we recommend that we continue to implement credits and hope to recertify for a platinum LEED certification. We would like to acknowledge Dr. Daniel Valliant for all of his help during our presentation and during his class, along with Jacob Gutter, Dave Johnson, Robert Handler, Tom Hoff, and Dave Krings. We want to thank these individuals for their expertise. We would not have been able to complete this project without them. Here are our references. And are there any questions?
Any questions?
So you mentioned briefly about CR, what was it?
CLT.
Yeah, cross-laminated timber.
So can you explain anything more about that or how it can help with the certification?
Yeah, so it's just a form of mass timber building instead of using like steel or concrete support. It's like 4x4 or 2x4s laminated in a cross pattern so that they're more structurally sound and can replace the steel and concrete materials.
So would the carbon dioxide that the trees, take in during their life, like the CLT, it uses a glue in between all of these panels, and so it helps prevent that wood from decomposing and like re-emitting that CO2. So it's a good carbon sequestration method. So, and then there's a lot of wood being used throughout this whole building, so it ends up really adding up to that carbon that it holds on to.
Would concrete still be used if it's implemented? Is it still?
Yes, but not nearly as much. We'll have concrete in the floors, I believe, and that will help with just like less vibration throughout the building and keeping things kind of quieter. But once again, much less cement would be used, cement and concrete would be used in that aspect than if we had a steel and concrete building.
So that was a great response. And just to clarify a few things, I think maybe a few of you might have come in the later presentations. Some of the teams earlier touched upon what mass timber is. So just to add, so CLT, as Madison said, it's taking conventional lumber essentially, and particularly lumber would be low grade lumber that would be discarded, and basically binding them together in layers with structural epoxy. And so it's basically turning crap lumber that would be thrown away into a high structural material. And so the big significance is that once you laminate everything together, it's now categorized as heavy timber. Heavy timber has really good fire rating properties. But these CLT panels, they're analogous to what we call precast concrete construction. So they get built in essentially kind of the same way in terms of panels. In terms of the concrete, technically speaking, structurally, we do not need that concrete topping. We actually designed it as a non-composite topping. So it's essentially there to provide mass to dampen out vibrations for the sensitivity of the equipment that would be in the building. But from a structural point of view, the CLT floor panels are designed to support all the weight. So you can eliminate all concrete if you wanted to. But is there any other questions? So, oh, yes.
How did you guys go about determining which parts of the LEED certification actually qualify? Was there some kind of reference book from the that you used? How would it actually get those points?
Yes, the USGBC goes into full detail about each credit, how you go about those credits, because there's different options, and like which option you choose determines how many points you could get. Also, we talked a lot with like facilities, and we were able to look at other LEED certified buildings, or like the GLRC, which isn't LEED certified, but it was built to be LEED certified. And so we're able to reference, because that's a similar building to the HSTEM building that's going to be built. So you're able to look at like water usage and energy consumption and make a realistic estimate on how we could get those points.
More questions? So I would completely 100% agree with this team in that mass timber buildings, if you're being mindful of sustainability and the environment, global warming, that's a big, huge issue now, right? Mass timber it's just a really hot topic right now because of that, because timber sequesters carbon, it doesn't release it into the atmosphere, and so it's a carbon sink. But you're actually paying a premium for mass timber. As construction management team will follow up and say, yeah, if you go with conventional materials, it's going to be cheaper. And that's what the actual HSTEM building that's breaking ground this afternoon, it's actually going to be a conventional steel framed concrete construction. I think a lot of that had to be driven through because costs. They did actually look at a mass timber building for the HSTEM building. These students, I did not tell these students that they actually did that, so it didn't affect their design space. But yeah, interesting note. I was at a conference last week in Atlanta. I learned something new about this. So LEED certification has been around for about 15, 20 years, and literally it's like the gold, or in this case, platinum standard of environmentally conscious, sustainable building construction. So I learned that there's a new one. It's like the next generation. It's called living building certification. It's like the next generation, and it's like way up there. Have you heard of living building certification? Okay, yeah. So I think one of the first buildings that was just built was on Georgia Tech campus, the Candela building. You could Google it, but yeah, the living building certification. So most of that building at Georgia Tech, they did a whole session on it and to highlight it. So it is mostly mass timber building for the reasons that it is sustainable, but they could not use CLT panels the way this group did because of the epoxy between the wood, because of the chemicals. So that would have violated the living building certification. It's going that far detail. So what they ended up using was a different form of CLT, but they called it DLT, dowel laminated timber. So instead of using epoxy, which they couldn't use because of the chemicals in the building, they used driven fasteners to layer up the layers. But I think the living building certification, most all buildings, it's not going to be practical to attain that certification, but it's kind of like the next generation. And one of the big things about this is, so once you get LEED standard, you get that at the get-go, but the living building certification, the owner is held accountable for a year after the building is built, and they have to submit all the energy consumption data, all that stuff to the organization to prove that they are a sustainable building. So I found that to be really interesting. So anyways, any more questions? Okay, well, thank you very much. 5 more minutes. The last presentation is at 10 o'clock by our construction management team. So again, if you're in this class, a student, don't scatter. Please stay, support your teammates, and we'll start in about 5 minutes.
I don't know if